Hello friends, so today we are going to do the questions from modern physics, and these questions are from the year 2020. Total 2 questions we are going to solve, and these 2 questions are from the advanced. And for the year 2020, this is part 3. In the first part we solved the question from the mains, and this is the final part for this 2020, in which we are going to solve the advanced questions, 2 advanced questions rather. So in the first question, a particle of mass m moves in circular orbits with potential energy Vr is equal to F times R, where F is a positive constant and R is its distance from the origin. Its energies are calculated using Bohr model. If the radius of the particle orbit is denoted by capital R and its speed and energy are denoted by V and E respectively, then for nth orbit we would find out these various options with respect to the radius, velocity and energy. Okay, so B and D are also somewhat same. So let us, it says that it moves in circular orbit, and because of the circular orbit obviously there will be a centripetal force acting on it. Therefore we can say centripetal balance for circular orbit. For circular orbit, and there is a force, positive force acting on it, and okay, so we can write that it is given that the radius of is capital R. Therefore from this we can write that our centripetal force mv square upon R will be equal to the force F, and from here we can say that our V square is equal to Fr upon m. Now from Bohr quantization you can write that Bohr quantization with respect to the momentum, we can write that our mvr will be equal to nh upon 2 pi, and from here we can easily find out our velocity v. So we can say velocity v will be equal to nh upon 2m times r, and we substitute this value of velocity, we are going to get this as nh upon 2 pi mr whole square is equal to Fr upon m. So we just open the square, we get this as n square h square upon 4 pi square m square r square is equal to Fr upon m, and here this m goes with the square, and from here we can write that our radius, which will be coming as cube, so our r cube is equal to our n square h square, and we have this as 4 pi square m times f. And in terms of, because radius options are in terms of our n proportionality terms, therefore we can write that our radius is proportional to n raised power 2 by 3. And velocity, if we substitute value of, let me call this as equation number 1. Okay, so if we substitute r in equation number 1, you can say, let me, from equation 1 we have that our velocity is proportional to our r 1 by 2, and if we substitute r as 2 by 3, n 2 by 3, so this comes as proportional to n 2 by 3 and whole raised power 1 by, sorry, it is 1 by 2, and this gives us that the velocity is proportional to n raised power 1 by 3. So we have our option number B is the correct one with respect to radius and velocity. Now we can find out our energy, and for energy we can say that energy E will be equal to K plus V. K is our, and V is our given to us as F times R. Okay. Therefore, this will be equal to half F times R plus FR. This comes as 3 by 2 times FR, and we can just substitute value of our R, and this will be coming as that our energy E will be equal to 3 times, and we have, one second, yes, so we can write this will be equal to our n square h square f square, and here will be 4 pi square m and whole raised power 1 by 3. So yes, let us call this equation number 2. So here this is using equation 2. Therefore the energy will be equal to 3 by 2. So option number C is correct. B and C are our correct options. Option B and C are correct. Next question. In an X-ray tube, electrons emitted from a filament, that is cathode, carrying current I, hit a target, that is anode, at a distance d from the cathode. The target is kept at a potential V higher than the cathode, resulting in emission of continuous and characteristic X-rays. If the filament current is decreased to I by 2, potential difference V is increased to 2V. The separation distance is reduced to d by 2. Then we have to find out what are the various options, and the options are related to our cutoff wavelength, and then it is about the wavelength, and it is about the intensity. Okay. So we can just summarize the question. Here it is mentioned that the initial current is our I, and this current is reduced to I by 2, and the corresponding voltage V, it increases to 2V, and the distance d, it reduces to d by 2. Okay, so this is the basic, the change. Okay, so initially we are having, let me write it here, that the initial we are having current I, voltage V, and distance d, and final we are given that current is our I by 2, and voltage is twice B, and distance is d by 2. Okay. So first of all, because ABCD discusses about the cutoff wavelength, so let us solve for the cutoff wavelength. So cutoff is nothing but our minimum wavelength. Minimum wavelength. Wavelength. And in this case we can, because for X-ray there is a law which is called as a Hunt law, or it is also sometimes called as a Duane Hunt law. Okay. So we can say Duane Hunt law, and it tells us that the lambda minimum wavelength is equal to hc upon E multiplied by V. Now we are going to double our this voltage. So we can say if V is doubled, so let us call the new wavelength is our lambda minimum prime, which will be equal to over hc, and this becomes E twice of V, or in terms of this lambda minimum we can write this as lambda minimum divided by 2. So it means our this cutoff wavelength is halved. Okay. So we can say that cutoff wavelength is half. So option A and C, because in both the cases it is saying that cutoff wavelength is reduced to half. Okay. So options A and C, and D and our B cannot be correct one. Okay. So from here we can say that our cutoff wavelength is halved. Cutoff wavelength is halved, and in this case we can, from here also we can see from the equations that independent of current I and distance d. And next we are interested in the characteristic wavelength of X-rays. Okay, so or we are also interested in the intensity of. Okay, let us start with the characteristic part. And there is a property of this characteristic rays, or sometimes they are also called as a characteristic lines, that they correspond to fixed atomic energy level difference of the target material. Okay. So we can say that our characteristic lines corresponds to fixed atomic energy fixed atomic energy level differences of the target material. Differences of the target material, and therefore the wavelength depend upon only on these energy differences. The wavelength depends only on these energy differences and not on current and the potential difference. Okay. So therefore, even if we change the current or potential difference, or one, it is also our D also. We have 3 parameters. Therefore, from where we can say that the characteristic wavelength remain same. Characteristic wavelength remain same. And from here we can more or less say that our option number A is the correct one, and next we have to find out our intensity part. Okay. So for our intensity, and with respect to intensity, we can say that our this X-ray intensity scales with the tube current. Okay, basically our the electrons, and as our intensity changes, the electron number of electrons that is being ejected is also going to change. Okay. Therefore, we can say our X-ray intensity scales with the tube current. So in this case, it says that the value of current was initially I, and finally the value of current is halved. And from here we can also write that the halves the number of electrons per unit time. Halves the number of electrons per unit time. Therefore, if we can say that the overall intensities for both continuous and characteristic, it decreases. Okay. Yes. So we can say thus overall intensities of both continuous and characteristic X-ray decreases. And thus we can say option C is also correct. Okay. And if you want to check, we can also, you can say with respect to D also we can just make a comment, because in the options there is no mention of D, but still we can just make a comment about that. And we are given that the distance between cathode and anode separation, that is D, is made as D by 2. Okay. And in this case, from here we can derive an important conclusion that this does not change kinetic energy of electrons, provided that potential difference V is fixed. If V is fixed, and this from D to D by 2 only affects the local field distribution. So we can say this, it only affects local field distribution. So it means this change from D does not affect lambda minimum or characteristic wavelength. Characteristic wavelength. Okay. So it means only options A and C are correct. Option A and C are correct. And sometimes this intensity part can also be explained by a formula. We know that our intensity I is equal to dN by dt multiplied by hc upon lambda. Okay. So as our dN by dt decreases our this intensity decreases. So these were the two questions that were asked in the 2020 advance, and this completes our this particular modern physics up till year 2024. Okay, from I think it is questions are from 1983 or 1984, something like that, and up till the year 2024. Next part we are going to start another chapter. Thank you.